Hello.
Hello.
Can can you hear me?
Check, check. Mic check. One, two, three.
Yeah, I can hear you.
Since the
Is Amelia online?
check, check.
Yeah.
Okay.
Right.
So let's get started, shall we? Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Welcome into the 3-in-1 program. Uh, Let me introduce myself. My name is Rion Halbercano, and I will be your moderator for today's lecture session. First of all, I would like to express my sincere gratitude for all of you who attending this session. Because in this session we have a very special guest who is a visiting lecturer from China. Everyone, please welcome Professor Dr. Zhi Li from Xiamen University. Good morning, Professor.
Good morning.
How are you today?
Good. So you can hear me?
Yes, we can hear you, Prof.
Okay. Good.
Okay, great. It is a great pleasure to have you with us today, and thank you for taking the time to share your insights and expertise for today's lecture. Before we get started into the session, there will be an opening speech from our lecturer, Mrs. Amelia.
Okay, thanks for the time for moderator. Assalamualaikum warahmatullahi wabarakatuh. Good morning, student and college, and the honor Professor Dr. Zhi Li from Xiamen University. Today we are very fortunate and honored because we have the opportunity to listen a lecture from an outstanding environmental economist, Professor Dr. Zhi Li from Xiamen University. He has extensive experience in the field of natural and environmental economics with his innovative research and significant contribution to the development of the concept of economic science. He has an impact in the global level. In this lecture, Prof. Zhi Li will link maybe ecotourism and environmental economics, as well as various important aspects related to the economics. I'm very thank you for Professor Zhi Li can attend our program and 3-in-1 program and take his time for us today. Thank you, Prof. And hopefully this lecture will not only provide new insight for all of us, but also inspire us to further explore and contribute to the development of science in the field of sustainable fisheries on our study program. Okay, I think enough for me. Then the time I give back to the moderator. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for the opening speech. And before we get started into the lecturing session, I would like to remind for all of the participants that the session will be 1 hour and 40 minutes long. So I encourage all of the participants to take your notes and prepare a summary, as it will be essential for your upcoming assignments. So without wasting any time, I will give the hand session over to Professor Dr. Zhi Li.
Yeah, thank you for the introduction. So before, I think we still have students coming in. I want to know a little bit the background of the students. So are they undergrads or master or PhD students? Are they?
Excuse me?
So are they uh, undergraduate students or master or graduate students?
Uh, Once again,
That's
please.
okay.
I can hear the sound, so good.
Can you hear me?
Yeah, I can hear you, but the sound is not too good.
Not so good.
Yeah, I'm sorry.
But can the students hear me clearly?
Yeah, I, we can clearly hear now. So
All right.
can repeat the question, please?
Uh, so are the students, they are undergraduate students or graduate students?
Undergraduate students.
Okay. Uh, good. Thank you for the opportunity. I think I want to. So I think before I start, because we are going to play some games today, some economic games, because games is part of my research tool that can be used to study many environmental policies, including fishery policies. So I think today I'm going to use this online session first to introduce the methodology. You can play some games before I actually can explain more how I can do research in fishery policies. So you need to understand what is the research tool. Um, Therefore, I think I ask Amalia to send the instruction for the students to register online platform such that they can play games today. Uh, I want to make sure all the students have received this instruction. So I think I'm going to first show you this show you this um, guideline to register uh, wait, I'll share. Let me see. Sharing. Where is the share the screen? Can I share this? Wait. Share. All right. Can the students see the screen?
Yes, we can see the screen, Professor.
So, I think can you help me to ask the student to check whether they have received the email to join the class? The website is here. It's edu.moblab /us.cn, and they can use the email that Amalia provide me to register online platform. Can help me to make sure the students. So I'm going to introduce the experiments approach first. I think I will use like half an hour, and during that time, I think all the students should finish this registration using their cell phone. They can register using their phone, and they actually, I assume they have the cell phone, right? Do they have a cell phone?
Yes, they all have
And
cell
they have
phones.
internet, live Wi-Fi.
Yes, we have.
Yeah. So then later on they can uh, use their cell phone. They can open this use this website and to play the games. I think that's part of today's lecture. All right. So I think I'm going to start to um, explain the methodology, and at the same time, because I think Amalia has this documents and have been emailed to all the students today for today's class. So I think during those half period, I think they can finish this, and then after I explain the background, we can play some games. All right?
Okay, Professor.
Yeah, good. So I've stopped sharing this. I hope all the students. I already see some students have registered, but not enough yet. All right. Okay. Let's see. Oh, and I'm going to share. Can you see my screen now?
Yeah, we can see the slide.
All right. So Amelia mentioned actually I do a lot of study on environmental economics. Uh, but I think before I explain how I do this research in environmental economics, I want to introduce the main methodology that I use for research on environmental economics, which is called experimental economics. Hopefully we can have some interaction. So I want to ask, or the moderator can help me to ask. Have any of you have heard of these experiments, economic experiments? If you have heard, maybe you can raise your hand. Because I think I can see I can see you, right? Have
Yeah.
you heard about experiments, economic experiments? Or how many of you?
93, sir. Prof.
No. I mean, have you heard about economic experiments?
Oh. Oh. We never heard of experimental economic, Professor.
No?
Yeah.
But so how is the student? So they can understand English very well? Should I speak slowly or I can use my normal speed to speak?
Maybe we can start it with slowly.
Okay. All right. Um, let's see. I will. So that's what I'm going to do. This. Change. All right. Because I want to see you guys, I will. Can I change this? Okay. Now, if you haven't, right, I'm adjusting my view to make sure I can get my mouse speed. Oh, this is good. Okay, now it's better. So, I'm going to introduce the experimental economics first, and then we will see how this approach can be used to study many environmental policies, including fishery. And later on, we're going to play actually some games for fishery. And if we have more time, I don't know whether it's today or some future time, I will show you because I use this experimental approach to study like fishery policies or different fishery management regimes, right? So this is our first lecture. I'm from Department of, let me use my laser point. Okay. So I'm from Department of Public Finance, School of Economics, and Wang Yan'an Institute for Studies in Economics. And you see we have a Finance and Economics Experimental Laboratory at Xiamen University. And this is my email. If you have any questions after the lecture, any like research questions, you can email me. All right. So today, this is the outline for today's class. I'm going to give you a brief introduction to experimental economics, including what are the economic experiments and the earliest ones, some history, and how we use experimental economics or economic experiments, the properties and the functions and applications. During that time, I'll explain how it can be used for do many environmental resource economic studies. And as I said early on, we're going to play some classic games. I hope you can play this use your phone. If you bring your laptop, you can also use a laptop. Um, and after you play the games, you get a better idea how we can use this as the tool to for research. And then later on, and when I introduce my research, you see actually how I can get the similar results. All right, so this is the plan. All right, first, what are economic experiments? So I think we are in the social science for fishery studies. I think it's part of sciences or fishery sciences. So you are not, I think you are kind of familiar with experiments. Maybe you do physics or chemistry, or when you study biology, you do a lot of experiments. The standard procedure for experiments, you observe data and then you form some testable hypothesis, and then you have prediction, and you do all kinds of tests. And then if the theory and the experiments are not the same, you modify your theory based on the experimental results. So this is what we call sciences, including fishery sciences. Now, for economic sciences, we want to do the same thing. So basically, we want to use a scientific approach to study economics. Maybe this will familiarize you with your own research. So for economics, for fishery, you can do some experiments. In economics, we can do the same thing. But what do we do with this economic sciences, right? So the key is we want to it's replicable, and we can use these experiments to test some policies, right? I think maybe this is easier for you to understand because you do a lot of experiments or not. I'm not sure. But in general, just like natural sciences like physics, chemistry, or biology, economic science, they have two components. For chemistry or biology, you have the object you want to study, and then you control the environment, control the temperature. For physics, you also control many factors that could affect the studied objects, right? Now, in economic experiments, the studied objects are actually decision making. So, for example, if you want to design a fishery policy, uh, and what you expect is how the fishermen will respond to the government's fishery policy. So the fisherman will be the decision maker in this environment. So the fisherman's behavior will be the object of this experiment. Actually, in social sciences, we do not call the object, we call them subjects. Okay, subjects. For example, if you answer some survey, you are the subject. Okay, so for economic science, the subjects are decision maker. We say we use subjects as economic agents in a controlled environment. Right, so this is a subject. Now, for the environment, that's like the temperature in many experiments. But for economic experiments, the environment is a series of incentive mechanisms, rules that characterize the economic system. Actually, those are the policy details. For example, in Indonesia, if you have some new policy for fishery management. Do you have total allowable catch, or do you have days at sea? So sometimes you have to close the ocean, so no one can go out fishing, right? So those are the policies, and maybe or you are thinking about maybe you heard of the individual quota. So the total allowable catch for individual at the individual level. Those are the policy details. Some other examples for economic environment. Maybe I heard right now Indonesia they have the carbon markets, right? So the blue carbon is the most like important thing in Indonesia. So how the offset market can work, right? The government will say how the initial allowance or permits can be allocated among different firms, etc. For any policy, you can think about fishery policy or fishery management rules. The details are the environments in economic sciences, right? I hope you get an idea. Actually, now we are using scientific method or approach to think about economic policies, and then we divide them into the decision-making elements, which we call the subjects, and the economic environments, which are a series of rules, policies. Okay, so as long as you understand this, now later on we can show okay how we can use lab experiments, or we call economic experiments, to study different economic policies, including fishery policies. And we see, okay, we should use this policy or that policy, which one is better? And now we can use economic approach to study this. And this idea of using experiment to study economics is actually initiated a long time ago. And in the world, we have economic science association. The reason we call this economic science because we use we call the natural scientific approach because we do experiments. That's what we call economic science association, which is found in 1986 by the Nobel laureate Vernon Smith. No, Vernon Smith won the Nobel Prize in 2002. Okay? So this is what are economic experiments? The earliest experiments is actually used for teaching, just like we are doing right now today, and to teach how the market works. All right. Um, but actually, initially, the whole story is in 19. There's one slide missing. Anyway, so in 1950s, when Vernon is a student, was a student at Harvard University. He attends. He was pursuing his PhD in economics at Harvard in the United States, and there's an economist called Chamberlain want to use this market trade experiment to show sometimes market doesn't work. And indeed, it doesn't work based on the classroom experiments. Werner was a PhD student at the time, but actually he didn't agree with his professor, his teacher. He thought actually the experiment was not correctly designed. That's why later on, after he graduated from 1955 to 1961, he redesigned a series of experiments and ran the experiments in his class, and actually it showed the market mechanism worked. And during that process, he established the experimental economics methodology called experimental economics induced values in 1976. And later on, he used this approach to study many important government policies and won the Nobel Prize in 2002. And this is the paper that got Nobel Prize winning, published in 1962 in the Journal of Political Economy, published by the University of Chicago. That's the early studies. All right. Now, what are the properties of experimental economics? The key is to use cash money to incentivize, or we say to motivate the participants to simulate the real economic environments and incentive structures. You can think of this from the perspective of fishermen. If the government introduce some new management policy to regulate or control fishermen's behavior, right? They may respond, but when they respond, they will think in their own, from their own perspective or for their own point of interest, right? So what we want to do is, in order to simulate this kind of response in the laboratory, we're going to use cash, use money. For example, if you play games, maybe in the future, if I were in Indonesia, or you visit Xiamen sometime, if you actually participate in some economic experiments, you're going to earn a lot of money, the real money. But the thing is, the amount of money that you earn depends on your behavior, depends on how you respond to the policies or to the environment. This is the difference between experimental economics to psychology. I don't know whether you participate in some experiments run by psychologists. Because psychology also run experiments. They ask you questions. They ask you to answer surveys or answer questions or read some graphs, etc. And then they will give you money, right, for your time. But how much money they give you is fixed. Is based on, for example, if you answer a survey for half an hour, how much money they give you is fixed. But in economics, how much money you earn depends on how you behave. That's what we call the incentive accountability. Think about if you are play if you play a simulated stock market game, trading stocks, right? Not everyone earn the same in the stock market. And similarly, not everyone earn the same in the economic experiments. So that's the key. This is the most important feature of economic experiments. And yeah, it's under control, it's regulable, and it's convenient and low cost. You'll see why later on. And the function is we can use this for teaching, just like today. And more importantly, it can be used, can be also used for testing theories. That's all the experiments, the basic function, testing theories, or identifying different theories, what's going on, what is right or not. If not, we can improve the theory. And most importantly, right, I would say the reason why the Vernon Smith earned the Nobel Prize because it can be used for policy evaluation. This is related to our topic, right? You study a lot of environmental policies. You're going to learn a lot of environmental policies or fishery policies. But sometimes you argue, okay, this is better than that, or policy A is better than policy B. You can have all kinds of arguments. If they say in theory, okay, you can also, if the policy is implemented, you can do some environmental studies. Or in computer, you can do some simulations. But that's all hypothetical most of the time, or is exposed. That means after the policy is implemented, you can see if it's better or not. But what if the government want you to design a policy or to revise a policy to say, okay, we have some issue right now. The original, the existing policy doesn't work well. Want to replace the one with a new one. Now you give me some suggestions. Want to use a new policy, and you want to argue, okay, I suggest you should change the policy in such way, and what will happen? How can you give a very strong argument when you want to say it? And now you've used this economic experiments, just like you did for fishery experiments, or if you do fishery sciences, you do all kinds of tests, right? If you do aquaculture, you raise different fishes. You want to do some experiment. You say, okay, this vaccine is better than that one. It will make increase the productivity of this fish. Okay, so you want to make that argument, you do experiment. And similarly, for fishery experiment, you can do the same thing. What we do is you can compare the existing ones with the new ones. So we can check, for example, we can under different parameters. When we say parameters, it's about different policies that different to achieve, or identifying testing outcomes under different sets of parameters of the system. It's either existing policy or something new that hasn't been implemented, and then we can use the policy evaluation. I'll give you some examples. Skip those economics. This is so sometimes the theory works, sometimes the theory doesn't work, but here we focus on the policy evaluation. This is Professor Charlie Plot. He's a professor in the Caltech. It's the California Institute of Technology in the United States. It's a very famous university. And he pioneered in improving the experimental methods and techniques using the findings from experiment to solve complex problems in reality. For example, the telecommunications frequency band auctions. and pollution quota trading design. You see, this is related to the environment and the fishery. Also, market clearing rules for government bonds, for Ministry of Finance, power market reform, water market, carbon emission, trading market, you see, fishery quota system, airport allocation. So see, all those are actually related policies. And he used this experiment to help design or revise the policy. Now, give you one detailed example from the Nobel laureate Vernon Smith. Okay, this is old example, but you see it's actually very important. Um, um, so this is the auction. All right. This is the auction of commercial radio spectrum by the called the Federal Communications Commission (FCC) in the United States. This is the most influential auction design in the 20th century. It involves billions of dollars, and the basic design and variant have been adopted in 6 different continents. The process is in 1993, almost more than 30, more than 30 years ago. Clinton signed a bill to say, okay, they want to auction off actually the bans for the cell phone companies due to time constraint, and they say, okay, how do we auction off? How to allocate those rights essentially, and they do is actually the FCC finds theoretical and experimental economics and auction off their lesson their scheme those rights to use the spectrum. And afterwards, the Congress required use of laboratory experiments, independent evaluate. You see, after they propose, so first when they propose, they rely on theory and experiments and to design how to propose this new auction, the spectrum auction. But after they proposed, actually the U.S. Congress asked external tests, also use these laboratory experiments to evaluate their auction before they actually implement. And the Vernon Smith actually participated in this evaluation and made suggestions, improvements of auction design. So this is one example. Another example is more recent. I see Charlie Plot from California Institute of Technology. What they do is actually in 2010 in Australia, they want to reallocate the electronic gaming machines. Gaming machine. The gaming machines is for casino, is for gambling. Is actually they want to reallocate this license for electric gaming machines. If you have the right to run a casino, you're going to earn a lot of money. So they are reallocating these 10-year entitlements for the use of electronic gaming machine. This involves how much money? More than 600 million. More than 600 million value of this 10 years entitlement, including 18,788 entitlements. All right. The thing is how to reallocate. The government need a policy, and what they do, actually, they find Charlie Plotz from California, and also Tiffany Kaysen from Purdue University, and the three other faculty members, and they help to design how to allocate, how to resell this reallocate this gaming machine 10 years entitlement. What they do is they first think about in theory, think about objective, and they design a software and a test using students, and later on they develop the platform. You see those cells, right? After they have developed a test, the whole thing, and then they implement this reallocation in one day in this computer-sized laboratory room. All the participants. So you see, there are 363 potential buyers. Those people sit in those cubics in front of the computer and to buy those licenses. This involves they have 176 interconnected markets conducted in one day, produced over more than 600 million in revenue. Right. So this is how we can use economic laboratory to design policy, and actually they use the policy, right? And after, of course, this is in 20. This is in May 2010, and after that, they also write a paper. They published in 2022. See how they use this game machine auction in Australia. This is country's experiments. Now I'm going to do another experiment, another policy example, how we can use this in China. China has launched a national copper market in 2021, July 16th. You see the date, 2021, July 16th. China has launched the national copper market. I think Indonesia also has the national copper market. The copper market is used essentially is a pollution permit market. If you are familiar with climate change, so the most popular policy tool for addressing climate change is the emission trading system. Essentially, it's just like a TAC, just like a total allowable catch. Just like want to protect we want to make sure we have sustainable fishery stock in the ocean, right? We do not want to deplete the fishery stock. The same thing in the climate, we do not want too much CO2, carbon dioxide, in the atmosphere. So we want to reduce the total emission. There's a cap, just like a total allowable catch. Now, once we have the cap, the thing is how the quota can be allocated among firms, just like how the fishery quota be allocated among the fishermen, right? What they do is they have the cap and the trade system for the pollution permits. Now China just launched this in 2021, July 16. This is the trading prices, and this is the trading volumes, and this is the first day. And actually, China right now is the largest copper market in the world in terms of greenhouses emission coverage. Now, you may think how to allocate the pollution permits or for any permits initially, right? You may have heard of like grandfathering. They receive for free based on historical record, or like in the European Union emission trading system, they can use, I would say, auction, just like the Spectrum or the gaming machine. They can use auction. Now, depends on which kind of markets you're considering. So for China, right now, we call it the benchmarking. So essentially, in some sense, similar to the grandfathering, or essentially we are saying the firms or the power sector, the coal-fired firms, they receive the pollution permits for free. Or you think about the fishery quota, maybe the fishermen receive their quota for free. But in the future, the government knows the free allocation is not very economic, efficient, or effective. So they want to introduce the auction. So they want the firms to actually buy the pollution permits from the government. Now the question is, what kind of the auction they want to use, right? Just like the spectrum auction. And actually, you think of the European Union emission trading system and the California emission trading system, they have different auctions. Is it revenue neutral or not? Well, which auction we should use? Actually, this is we do not know, or especially in the context of the China's national carbon, which one is better? The government wants to know. So what do we do? Actually, we designed the auction and we develop like a software, like economic games for students to play. We compare different auctions. Like the baseline is the China's free allocation, and we also ask the people or the subjects to play European Union's auction and also the California's auction. And this is me, and I collaborate with two professors from Tsinghua University who are more involved in the policy for the carbon market, and we design this. And we have the policy report for the government to tell them, okay, which one is good, which one is better, which one depends on their objectives. Okay, so that's the how we use economic experiment, and this is environmental policy. Can see how we can use economic experiments to help design, evaluate environmental policies, and that actually can influence the government of decision makers or policy makers, right? Those the examples. Of course, I will skip this one. The economic experiments can also, especially right now, we have a lot of AI or machine learning techniques, and they are also related. But this is not the focus today, so I will skip this one. So for now, I have explained the background for economic experiments, and if you are interested in, you can see those are the related Nobel Prize winners in behavioral and experimental economics. From the earliest, 2002, this is Vernon Smith, I already explained. In the same year, another psychologist who studied behavioral economics, Daniel Kahneman, also won the Nobel Prize. Okay, I want you to know to the difference between the behavioral and experimental economics. For experimental economics, generally we study the game with at least two players. So we should have at least two players. So we have a strategic decision making. Just think about the fisherman, right? You think you go out fishing. It's not yourself. There are many other fishing boats. So if there are fish there, you can think about which spot I should go. It could be crowded. So you have a strategic interaction. But for behavioral economics, you may have one player. It's an individual decision making. For example, there is a investment. You want to make investment or not? It's more individual decision making. So this is the first year the Nobel Prize was awarded to economics and the psychologists. In 2012, Ross, who is also at Stanford right now, he studied matching markets, how to find a job, kidney change, etc. When there's no price for the good, then how to allocate. In 2017, Richard Saylor, he's economics at the University of Chicago. He studied behavioral economics. And in 2019, these three economics actually they use experiments as an approach, like experimental approach to alleviating global poverty. RCT we call random control trials. They use experiment to study we call development economics. And lastly, in 2020, we have two, again, Stanford theorists, economic theorists. Actually, they study auction. They are not doing experiments. The reason why I list them there is because the reason why they win Nobel Prize is their auction theory is implemented in reality for the spectrum auction. I explained how what this means, what's involved in the process, right? Actually, why did Nobel Prize they can earn this Nobel Prize is their theory is put into action. And why? Because experiments play a very important role, a key role to make sure their theory is implemented, right? So this is the a general background. And to show you this is our lab at the Xiamen University. Actually, the students can play the games in front of the computer and test all kinds of policies, economic policies, including environmental resource policies or including fishery policies, right? Actually, we have this lab. I think this is the brief introduction, and I give you some references if you want to learn more. We say economics as engineer, how we can use experiments to inform policy making. And lab experiments are a major source of knowledge of the social science published in Sciences, and the role of experiment for policy design. Those are available online. You can check. And there's you see in 2023, the National Academy of Sciences, Engineering, and Medicine in the United States, they also published a report called Behavioral Economic Policy Impact and Future Directions. And these are for your references to learn more of this policy tool. Do we need to have a break over time? Then I will check. I can set up. Hope all the students can set up. Now, what do we do next is actually we're going to play some games. Now you know the background. We give you some hands-on experience how the experiment is like. And then you can see how we can use these experiments to inform some policy design issues. So I'm asking, do we have a 5 or 10 minutes break? Do we need?
Yeah.
I think for that time the students can. Hello?
Yes, Prof.
Do the student need a 10 minutes or 5 minutes break?
It's okay to have a 10 minutes break.
Yeah, but during that break, I hope let me show you this this again, so make sure, let me see. So during that break, I hope all of the students, now you finish the registration. So after the break, we can play some games, including a fishery game, right? You're going to play some fishery game using your cell phone. If you have laptop, that's fine too. If otherwise, um, you can use the your cell phone. Is that okay? So we start at 11.
Yeah.
So your time will be 10, right? Your time will be 10.
Yeah. In 10 o'clock.
All right. So let's have a break, and I hope other students now you should sign up for the website using the email you provided to Amalia. All right. Okay.
Okay, Professor.
All right. So you can see so also you can scan the QR code using the browser, sign to student console, or you can just join with this QR code, right? Use your cell phone to scan the QR code. Already, I think I already see more than 30 students have successfully signed up. I can see more than 30 students, but I think you have in total around 90. That means we have still have more than 6 students need to sign up, right? Hello? Can you hear me? Let's see how many of you. What? Yeah, I know it may take some why not right. So so first you need to check there should be a invitation email sent out last night to your email account. I think Amelia gave me the email address, and you should be able to receive an email in your email accounts. You can check the spam folder if it's not there, and there should be some link. You can click that, so then you can register for the class. But before that, you need to use the email address to create an account. Also, I think the email has been sent out maybe this morning or last night. Not verified. Okay, so maybe you do not have. So let me see. Or maybe I can ask, or can the moderator help to ask for the students who have successfully signed up? Can you raise their hand? Can I check? At least, so if not all of you have signed up, but at least you know who has been signed up, so you can watch them when I start the game. At least from what I can see is one, two. Yeah, there should be more than 30, more than 30 students. Have you signed up? Can I give me some feedback, moderator?
Yes, Professor?
Can you ask the students how many of them have successfully signed up? Raise their hand. I can have a look. Their cell phone.
I think everyone is already successful to sign up.
Oh, really?
Yeah.
Okay. Good. Then we can play games. I will show you. So first we're going to play some simple games. In the end, we're going to play a fishery game. All right. So that's the plan. Let me share my screen. So for the fishery game. All right, can you see my screen for the Experiment Economic Classic Games?
Yes, we can see the screen, Prof.
All right, good. We're going to play some game. So this is the second half for today. So first, just remember to play games or to do economic experiments. Your objective, what do you want to get? You want to maximize your own payoff. It's just play online games. And you are undergrad students, you must have played some maybe video games or online games for fun. So for those games, you want to maximize your points, right? So the points in economic games is called payoff. So in real experiments, in real economic experiments, those points later on is going to be changed to real dollars. like rupees, Indonesia rupees or US dollars, yeah, you're going to give you really cash. But for this course, I heard the moderator said, okay, you're going to have some assignments. Now, for the lecture given by me, your grade is based on your performance in the experiments. How many we call it experimental currency or experimental points you're going to earn in the game. That represents your payoff. That's represents your grade. All right. So this is your objective. We're going to play the first simple game just to make sure you can get started. All right. I have prepared many games. So we'll play some simple ones to get you warm up, so you know what's going on, and then we play a fishery game, a simple fishery game. The first game we're going to play is called the guessing game, guessing the number game. So what do we do? So now you got your objective. The next is going to learn the rules. For example, the fisherman need to know the fishery management regulation rules. Now, as a player, you need to know, okay, what is the rule? So I'm explaining the simple rules. So you're going to play 3 times. Each time we call each round. In each round, okay, you're going to choose a number between 0 and 100. It's an integer, like a 0, 1, 2, 3, 4, etc. until 100. Integers. You're going to choose a number. You choose a number, then you submit the number. And the computer will calculate the target. And this target is equal to the average of all the choices times a multiplier. For example, everyone in the group, we're going to choose a number. And we're going to calculate the average of the numbers submitted, the mean or the average submitted by your group members. And the average will multiply it by a number. That number is called the multiplier. What is the number? Is 2/3, which is 0.6667, or something like that, right? So that would be the number. And the winning choice, this is a game, so somebody need to win, right? So the winning choice is whoever submitted the choice closest to the target, which is the 2/3 of the group average. And the prize will be evenly split if they have more than one player choose the same number, which is closest to the target, then it'll evenly split. Otherwise, whoever choose the number closest to the 2/3 of the average, we're going to win this game. Okay, it's very simple. Just choose a number, and you will see whether you're going to win or not. Or everywhere else will win nothing, right? So later on, if you open the website or scan the QR code, you're going to see a screen like this. So you see there's a slider. So you can move the slider by choosing. Now it's a 0. You move the slider up to 100. Use the slider, choose a number. All right. So for example, you choose 16, and then you click submit. That means you have. So you move the slider and you click the submit. Then you have been chosen. You have chosen this number. And then the target, you see, it will be 67% of the group average. So whoever is closest to 2/3, which is approximately 67% of the group average, will be the winner. Will win 20 points. All the others are going to lose. Okay, so you want to win. Right? Give you an example. We have 6 players. The choice is 18, 33, 36, 65, 72, 80, 82. And multipliers 70.67. Calculate target. So the average is 51, and the target will be 51 times 30.67 will be 34, around 34. So now you think about who is going to win. Who is the winner? Whoever is closest to 34.17, right? Which is 33, right? Whoever chose 33 actually win the game, right? So this is the game we're going to play. Do you understand?
Yes, we understand, Professor.
All right. So wait a second. Let me start the game. All right. So now everyone should log in the website. I'm going to. So how many students in the classroom right now? 30? That's 90?
93.
93? All right. So I will sign up like 10 students in one group. Okay, 10 students in one group. And we're going to play 3 times. We're going to play 3 times. So this is a simple game. Just make sure you know how to sign up and how to play and familiar with the whole website. Now, okay, I have started the game. So the students now you need to sign in the accounts, and now you see there's a screen pop up. There's an active session, and you just play that game. I haven't seen anyone. Okay. Yeah, I see 5 participants. Yeah, at least 5. That's good. Now 18, good. Don't worry, this is just okay. Now we have 34. I have seen 34 students now. Good. So this is the rule. So no hurry. If you now we have C40 54. Good. That means you have signed in. Almost 60. Good. Yeah, more than 60. Yeah, we have 78 students have signed up now. Well, there are 72 have been played the game. And we're going to show you the winner later on. $77. Good. Now you're in the second round. Um, yeah, most are in the last round. All right. Are you having fun? I think I cannot hear you, but I can see. All right. Let me show you the result a little bit. All right, to see. You may guess. Okay, probably you can. Uh, uh, I think you can see the results, right? I don't know what's your name, the moderator. How should I call you? uh, the student can see the results, right?
Yes, Professor.
Yeah, you can. Maybe you can. If they can they speak English? If they can, maybe can one student can say something to let me know what do they are thinking. I think someone is raising the hand. You can in the audience. The student just right behind you. I think. Yeah, you can see something. You can give the mic to him, the student. Can you give the microphone to the student to say what do they found?
Give the microphone to the winner.
Yeah. The winner can say something. Or not necessarily the winner, but whoever wants to speak. Anyone want to speak?
Check, check.
Yeah.
We have our first winner here. Please introduce yourself.
Um, good morning, Mr. Professor. Good morning, Professor. My name is Aulia, and I'm the winner. I'm the winner on the number contest. So
Okay, what is your strategy? You can speak a little bit.
Can you repeat, Professor?
What is the strategy? How do you choose the number?
honestly, I don't know. I don't know how to I'm the winners because in the screen on my phone, I choose 28
Choose 28. All right. Let me
because
show
because my
you.
answer is less
Uh,
less the
good.
50.
Don't worry. I will just show you. Good. Can you see the screen?
Yes, Professor.
Yeah, I think he said he's 28. Let me see. Do I have a 28? Yeah, there's a 28 winning choice. I think group 5. Yeah, this is the winning 28. All right, you can sit down. That's okay. So I think you play period. So what is the winning strategy? I will explain a little bit and help you to think what is the strategy. What is the strategy? It's an economic game, right? If you imagine if everyone is choosing a number randomly, right? There could be anything between 0 and 100. So on average, it could be 50, right? 50. But the winning policy is need to be 2/3 of the average. So what is 2/3 of 50? 2/3 of 50? 33, right? 33. Then you may think, okay, I should contribute to 33. But at the same time, you would imagine, wait, if I contribute 33, my classmates may also contribute 33. So everyone will contribute 33. Then, what is the winning strategy? 33, the average will be 33. Then you should contribute 2/3 of 33. That will be 22, right? So you see we have, let's see, you see, this is group 6, winning probability, winning choice, 22, because the average is 36. So this is the thinking process. Of course, you can continue to think. We have different winnings, like 19 or 24, or you can see the table 19, 24. You are pretty good, actually. And we call this the level K of thinking. This is period 1. If I go to period 3, yeah, depends. All right. So this is a game you play. I just want you to think about this. This is how we play a game strategically, right? We do not have sufficient time to explain more, but now let's go back to play a fishery game, right? We're going to play a fishery game today. I'll show you the screen. but I think you get the point. What is a game? Allow me share my screen for this. Share. Okay. So, can you see the screen now?
Yes, Professor, we can see the screen.
And now I'm going to skip a lot of things. We have time, we can play more games, but I think let's go to the fishing game. Did you see the screen fishing game?
Yes.
Alright, now let me explain the fishing game. Okay, we are going to play multiple rounds, right? Each round, each player will simultaneously choose how many hours to fish. This is how you choose. Each player's revenue, the money you make, depends on the number of hours you fish by the group. The more hours fished, the lower per hour revenue. I think it makes sense. There's an ocean, and then if you're many fishermen, then the fish you catch will become less, right? Catch less fish. They will use hours of fishing to represent the fishing effort. And the profit, that is how much money you make, depends on the revenue per hour times the hours you fish. The revenue per hour depends on the total hours of a group. And you can decide on your own how many hours you want to go fishing. Each player can choose up to the max hours of fishing. I'll tell you later what is the maximum hours you can choose. Probably think is 40 hours. Right? Now the screen. You see the screen like this. The total fishermen in the area, you can see. I will let you know the number later. Let's assume right now you have fishermen in the group, right? And you can use the slider to estimate the revenue per hour. So others, the average hours 11, and your hours is 17. Then the revenue per hour is 168. So that's you can estimate how many hours you want to go fishing. Right? Now you can use the slider to choose your hours of fishing. So here in total you have 40 hours. Now here you choose to fish 17 hours on the ocean. That means you have, let's see, so you have 23 hours not fished. But realize the revenue per hour of fishing declines with the total hours your group, right? Declines. So this is help you to make your choice, make a decision. Now, like a fish 17 hours. This is the button. So you can estimate how many hours to fish and the revenue per hour, and then decide how many hours you're going to fish. And after you think about it, you use the slider to choose, and then you click the button. If you click the button, that means you have determined how many hours to fish. How many hours to fish. All right. Now how much money you make. So here shows the result. You fish 17 hours and actually going to win $2,227 in the game. All right, and this is your earnings. And the market report, you will see 5 other fishermen average 18.4 hours. In total, 109 hours out of 240 hours were used. So you have 6 fishermen. Each fisherman can go fish up to 40 hours. In total is 240 hours. But you actually used 109 hours in total. All right, so this is explain your profits. Okay, we have many fishery biologists in the audience, maybe. There's a report. You see the fishery stock. Is it good or not? And the healthy lake leads to, that's, I don't need to explain. You know the fishery. All right. So how you make money? How do you make money? So each boat has a maximum of hours of fishing you see from the screen, and the revenue per hour depends on the maximum individual hour times the group size minus the total hours fished by a group. So the maximum is given, and the total hours, if you increase the group member total hours, so it's not on your own, it depends on every group member in your group. The total hours determine the revenue. But the more hours you fish, the lower the revenue per hour. And your payoff will be equal to revenue per hour times hours of fishing. Here's an example. If 6 boats fish up to 40 hours each, and then let's say the group fishes 120 hours. So in total, actually, you have 240, and your group hours equal to 120. That means the revenue per hour will be 240 minus. I can write out this for you. So this is 240, right? Minus 120. So the revenue per hour will be 120. And you fish 30 hours. 30 hours. So the profit will be 3,600. All right? So this is a simple game. Simple game. So let's play this. Do you have any question? Are you clear?
Yes, Professor.
All right. Now I will, let's say, you keep saying, let me start this game. Let's see. Uh, let's keep it simple. We do not. Let me see. 1 hour, 1 minute. Yeah, we're going to play 5 periods. And total players 6. Just use the same number, right? Just use 6 number. 6 players in a game. We play 5 periods. Now, okay, it has been started. Need to sign in. So right now we have more than 30 students. The same website. You still keep login, and you can refresh the browser that you see actually.
Oh, ya ya ya. Jadi kalau kita lebih hemat dari kemarin-kemarin, nanti besoknya itu kita lebih banyak dapatnya. Enggak. Ini gua 20 jam tapi lebih jadi $200 per jam. Waduh, unhappy.
All right. I think you're having. Are you having fun? So, due to time constraint, I'm going to stop. I'm going to show you the results. And so you are studying fishery, economics. Let me see. Pure one. Group hour. All right. I think you have in a few minutes you have a different course, so I'm going to briefly explain. Right? I think you can see the screen. Actually, probably you figure out this is fishing graph. They show you the total group profits depending the hours, and the green one 120 is socially efficient, and this red one is a national equilibrium, and this yellow triangle is a mean group hours, right? Only play. This is the first period. You see, medium is 100 something, not the socially optimal. You should produce more. This is first period. The second period, you only produce 40. That's you're not you're not catching sufficient. So you are a fisherman. you're not maximizing your profit. Anyway, let me yeah. Uh, uh, I will see the aggregate. I don't know whether you are so conservative. You should produce more, make more money. But I think I use this to demonstrate how we can. But now there's no policy, right? Just open access. Anyone can produce. If we have next time, we can arrange for next time. Actually, I will show you. You can play a little bit more different games. So what if we have different policies? You have a fishing quota or not? How the behavior will change. But today you learn how we can use economic experiments to study fishery policies. And next time, if there's next time, I'll discuss, for example, my research. If I use different policy, how to play different, more complex games, and you can play a different game, like individual quota, how would that change? You can have more time to play this game and to see how we can use this economic experiment study around policy. All right. I will stop here. So this will be for today, I think. Yeah.
Okay. Thank you, Professor Dr. Zhi Li, for the lecture and the insightful and engaging lecture that we receive it. We deeply appreciate your time and expertise. And thank you for all the participants who wants to take the participation and active. So before we close this session, can we take a picture for documentation? Okay.
Should I? All right. Sure.
Okay, everyone ready? 3, 2, 1, say cheese. Once again. 1, 2, 3. Okay. Again, thank you very much, Professor Dr. Zhi Li. I hope we can meet again.
Yeah. All right.
Okay.
I will leave the room. I think there's
Yeah.
another. You have another course, right?
Thank
Okay.
you, Prof.
Hope you are having fun. All right. Bye bye.